Welcome, geometers. This is the very last day of notes. Pretty exciting. You'll never have to listen to my terrible pre-recorded lessons ever again, unless you're in my class next year and we have to do this again, which, dear God, I hope neither of those are true. Burn. Anywho, here we go. So today's lesson is on applications of trigonometry. So I'm going to go through and just show you, we learned right triangle trigonometry. We learned the law of sines. We learned the law of cosines. So I'm just going to go through and give you an example of each one of those. And then, every problem's different, and you just got to think about what's asking you, start drawing in the diagram, and then you'll finally see which type of trig to use. So, for instance, this problem's asking me to find the area of a parallelogram. So like in any of those multi-step application problems we did back in chapters 8 and 9, I'm going to do this with backwards design in mind. So in order to find the area of a parallelogram, well, what's the formula? And it's base times height. So what do I need to know? I need to know the base. I need to know the height. So remember, in a parallelogram, the base and the height need to be perpendicular to one another. So I'm going to use a base of 18. And then I need a perpendicular height. Now you notice this side length of 10 is given to me, but that 10 is most certainly not the height of this parallelogram because it is not perpendicular. So what I will do instead is I will draw a height in, and I'll draw it in such a place where I get a right triangle. So there is my altitude, or the height of this parallelogram, and what I need to do is to find that little h. So by working backwards and thinking, hey, what do I want at the end? I want the area, all right? And then I could draw my altitude, and I can determine, hey, I need to find h. And what you should notice is that, hey, I got a right triangle here. So I'm going to use right triangle trig with this right triangle. So here it is, and I will do that to find h, or the height. So, but you'll notice I have an angle measure, rather, 65 degrees. I don't have any side lengths. But remember properties that we learned about parallelograms, and that's opposite sides are congruent. So this is 10. So now I have my right triangle here, and in this right triangle, relative to this 65 degrees, this is the opposite side, and relative to 65 degrees, this is my hypotenuse. And if I think about my acronym SOHCAHTOA, I see that I need to use sine. So I know that the sine of 65 is equal to opposite, which is h, the height of the parallelogram, divided by the hypotenuse, which is 10. So that means that the height of this parallelogram, when I multiply both sides by 10, is 10 times the sine of 65. All right, so over here in my formula, I got area is base times height. So area is 18 times I found the height was 10 times the sine of 65. So notice I'm not going to round anything until the very end. So here we go. The area of this parallelogram, let me get out my calculator. Again, make sure you'll notice I just typed in sine of 30 and got 0.5, made sure it was in the correct mode. I'm going to do 18 times 10 times the sine of 65. So the area will be 163, roughly 0.1 kilometers squared. There we go. So in that process, I was like, all right, I need to find area. I drew my height. I got a right triangle. And because it was a right triangle, that's when I go to SOHCAHTOA. All right, so the next problem is also another example. This is one you'll see a lot of, in fact, in your homework assignment. And actually find out the area of a lot of regular polygons. All right, and we'll walk through the process. So find the area of the regular octagon shown below. So remember, backwards design. All right, well, how do you find the area of a regular polygon? It's 1/2 times the apothem times the perimeter. And then I'm just going to go ahead and see what I have and what I need to find. Well, what's given to me is a side length. All right. And in an octagon, there are 8 sides. So I can find the perimeter pretty easily by doing 12 times 8, which is, 96, I believe. So 12 times 8 gives me a perimeter of 96. And now I got to find the apothem. So to do that, here are the steps. And pay close attention, all right? The first step is to draw 2 consecutive radii that give me a central angle. Now remember, if I drew all of those radii, I would end up with 8 of these isosceles triangles. And I guess I can go ahead and show that to you. Why the heck not? I've done this a bunch. But if I draw all of them, you get 8 congruent isosceles triangles. And so to find my central angle measure, which is the next step, all of these angles, I didn't draw those radii very well, did I? All of these angles add up to 360. And 360 degrees divided by 8 equal angles is 45 degrees. So each one of these is 45 degrees. So then I will draw my apothem. Now, when I draw my apothem, when I draw my apothem here, I cut this isosceles triangle into 2 right triangles, because an apothem is perpendicular to the side. All right, so now this is where I'm going to use right triangle trigonometry to find the area, or excuse me, to find the apothem, or what happens to be a side length of this highlighted right triangle. All right, so here's the apothem, what I'm looking for. And if this entire side length was 12, which was given to me, then just this little guy is 6. And the other thing I know is that if the entire central angle is 45 degrees, when I draw my apothem, this is half of that, which is 22.5. And my handwriting's terrible. So I'm just going to draw a separate little right triangle over here, showing you what I'm working with. But this is this highlighted right triangle. This is 6. Here's my right angle. This is my apothem, what I'm looking for. And this is 22.5 degrees. So relative to this angle, this is opposite. This is adjacent. So I need to use tangent. So the tangent of 22.5 is equal to opposite, which is 6, over adjacent, which is A. Now in this case, the variable's on the bottom. Now remember, in this previous problem when I did my trig stuff, the variable's on top, so I just multiply both sides by 10. If you'll recall, when the variable's on bottom, that little division trick, we just swap the trig part with the variable. So that means the apothem would be 6 divided by the tangent of 22.5. So I'm just going to take this, and I'm going to substitute it in right here. 6 divided by the tangent of 22.5. And again, sorry for my terrible handwriting. And now all I got to do is go to my calculator, and it's 1/2 times the apothem times the perimeter. So I'm going to do 0.5 times the apothem is 6 divided by the tangent of 22.5. Make sure I close that parenthesis. All right, and now I'm going to close this other parenthesis. So I've got in this parenthesis 6 divided by the tangent of 22.5, and then times 96, the perimeter. So the area of that regular octagon is about 695.3 centimeters squared. 695.3. Centimeters squared. And in your homework tonight, or the assignment, you were asked to find the area of quite a few regular polygons. And so that's the process. You draw the radii, you get the central angle. Draw the apothem that bisects the central angle, and then use that right triangle to either find the apothem, or if the apothem is given, you can find this little half side length, and then use that to find the perimeter. All right? So again, the goal for all these problems is, hey, can I make a triangle? That's what this entire unit is about. And it will just come with practice. And if you have questions, of course, just reach out and we'll help. All right, so next is an example of a problem where we're going to apply the law of sines. All right, now, and typically when I give you a problem, I'm not going to say in the directions, hey, use law of sines. You're going to have to determine that. So this problem, working backwards, says to find the perimeter. All right, well, how do you find the perimeter of a rhombus? You simply take one side length, we'll call it S, and because it's a rhombus, all the side lengths will be the same. So the perimeter of this rhombus is simply 4 times S. Okay, well, you just got to find the side length. So to do that, I'm going to use some properties. And so what I know is when I draw this diagonal, FH, which is drawn in here for me, I form 2 isosceles triangles. There's this guy on the left and this guy on the right. All right, and in a rhombus, opposite angles are congruent, so I know that'd be 40. And if these 3 angles add up to 180, and it's an isosceles triangle, and these angles need to be congruent to each other, well, then each of these would be 70. 70 and 70 is 140, and another 40 is 180. So in this case, I'm going to use this non-right triangle, this oblique triangle, which I will highlight here or fill in if I can find that option. Where is it? There we go. All right, so I'm going to use this oblique triangle, and I'm going to use the law of sines. And the reason I'm going to use the law of sines is because you'll notice I'm given an angle, the side across from it. I have this angle. I want to find the side across from it. So I can just tell based on what's given to me what I want to find. An angle, find the side across from it. Give it an angle, you know the side across from it. This is simply a law of sines problem. So I would just say the sine of 70 divided by s is equal to sine of 40 divided by 10. When I cross multiply, I'm going to get s times the sine of 40 is equal to 10 times the sine of 70. Then I'll divide both sides by the sine of 40. And I get that s, or the side length, is 10 times the sine of 70 divided by the sine of 40. All right, so what I'm going to do now is I'm simply going to punch that in my calculator and then multiply it by 4. So I'll show you my work. Here we go. So I'm going to punch that in my calculator and then multiply it by 4. So that's 10 times the sine of 70 divided by the sine of 40. And it gives me one side length. And one side length is about 14.6. That makes sense in the context of this problem. You know, the 10 length side is across from 40, so the side across from 70 should be bigger. 14.6 roughly makes sense. But that's one side length, and this problem asks for the perimeter. And in a rhombus, are all the same, so multiply by 4. And the perimeter of this guy is around 58.5. And what are that's inches. 58.5 inches. So the perimeter, 58.5 inches. Great. All right, and then the last problem here is, here's an example of the application of law of cosine. So in this problem it says to find the length of the diagonal, so ik, we'll just call it x here. All right, and it's isosceles trapezoid. Now the fact that it's isosceles helps me out one area, and that's the fact that these legs are congruent, so that gives me 13. So what I'm going to do in this problem is I'm going to find this diagonal. You'll notice what's given to me, and I'm going to focus on this triangle here. Let me see if I can highlight it. I'm going to focus on this triangle right here. And this is a law of cosines application. And the reason I know it's a law of cosines is because I've got a side, an angle on a side, and I want to find this third side. So again, with all these problems, you really need to cut these things into triangles and then see what's given and determine if it's a right triangle, use SOHCAHTOA. If you have side, angle, side, and you want to find the third side, use law of cosines. Just getting used to knowing which one to use. So setting it up, law of cosines is c squared equals a squared plus b squared minus 2ab times the cosine of c. So I'm going to plug in. Remember, this dude all by himself over here, the one across from that angle in the side angle side situation, is c. So x squared equals, I'm going to call this little guy a, this little guy b. So I got 13 squared plus 22 squared minus 2 times 13 times 22 times the cosine of 70. So all I'm going to do now, you guys, is I'm simply going to plug this into my calculator, and then I'm going to square root it. So x squared is equal to, let's do this, 13 squared, oops, what happened? 13 squared plus 22 squared minus 2 times 13 times 22 times the cosine of 70. Just double check everything looks good. 13 squared, 22 squared, minus 2 times 13 times 22, cosine of 70, everything looks good. That's x squared. So x squared is about 457.36. And now I'm just going to square root that because I don't want x squared, I want x. So let me square root that answer. And I get that x is around 21.4. And in this case, it would be feet. One little dash there is feet. And just see if it makes sense, you know, across from 70. Yeah, it makes sense relative to these other numbers. So the idea, you guys, is with all these application problems, just draw and see what kind of triangle you get. And then based on what's given, that'll tell you what to use. All right, good luck.